You know, if you just read the headlines today, you've probably heard the dark web described as some sort of secret criminal internet, right? It's a super catchy phrase, it's highly sensationalized, and honestly, it makes for a fantastic movie plot. But it's also only a tiny sliver of the actual picture. It kind of mixes together a whole bunch of different ideas and leaves the real system completely blurry. So welcome to this explainer. Today, we are going to completely strip away the drama, the mystery, and the rumors. Instead, we're going to build a really calm, logical, first principles understanding of what this system actually is, how it works, and why people genuinely use it.
Okay, let's dive into this. We've got a great roadmap ahead. We're going to break things down into 4 parts. First, the dark web myth. Second, engineering, not magic. Third, privacy versus secrecy. And finally, number 4, the danger of false confidence. All right, part 1. The dark web myth. Let's separate fact from fiction. First up, we absolutely need to tear down some catchy, but honestly, totally inaccurate ideas. The biggest confusion almost always starts by mixing up the deep web with the dark web. So, the deep web, that's simply content that isn't indexed by normal search engines. Think about your private email inbox, your online banking portal, maybe a student records database. It's massive, but it's mostly normal everyday stuff. The dark web, on the other hand, is a very specific part of the internet that is intentionally hidden, and it absolutely requires special software to reach. Let's think of the internet like a giant building complex. The surface web, that's the shops on the main street, easy to just walk right into. The deep web is like the private offices inside where you need a door code or an appointment. But the dark web, well, that's a set of rooms that don't show up on the public signboard at all, and you need a highly specific, specialized key just to find the entrance.
Now, because those rooms are hidden from ordinary visibility by design, people automatically assume the worst. But listen, while illegal activity is absolutely something that can happen there, it is not the definition of the dark web. The definition is entirely about how access works, the literal fact that it's hidden, and not what people are actually doing once they get inside.
Moving right along to part 2, engineering, not magic. Let's look at how it actually works. Once we understand that we're basically just talking about a hidden layer of the internet, we really have to look at the mechanics. Saying something is hidden by design sounds simple enough, but it immediately raises a fundamental question. Hidden from whom exactly, and how? Look, this isn't magic. It's a series of very deliberate engineering choices designed specifically to create intentional friction for outside observers. To create that friction, these hidden networks focus on obscuring 3 core elements: your location, your identity, and your traffic patterns. Think about ordinary internet browsing like sending a package to a known address. If you know the address, hey, you can deliver it. Hidden networks flip this on its head by removing that public address. It's exactly like using a food delivery app. You interact entirely with the platform's buffer. You never actually see the real physical address of the kitchen that's cooking up your midnight burrito. By hiding the location and identity, the network makes it significantly harder for anyone to monitor, block, or attack the server. And this brilliantly illustrates exactly how they pull that off, by splitting up knowledge across the path. Instead of one single computer knowing everything, the system relies on many small barriers. One part knows where a message came from, another part only knows where it's going next, and yet another part only knows the content it's relaying. It's literally like a relay race where each runner only carries the baton for a short distance, and no single runner ever completes the whole race alone. Because the journey is broken into these isolated segments, no single point in the network ever gets the full story.
Now, you might be wondering, wait, doesn't regular encryption do this? Well, not quite. There are 2 totally different goals here. Message encryption basically means outsiders cannot read the content. It's like mailing a sealed envelope. People can't see the letter inside, right? But connection obscurity, which is what hidden networks do, means outsiders cannot even tell a connection happened in the first place. It attempts to hide who sent the envelope, who received it, and exactly when it was sent. It's hiding the entire relationship between users and services, not just the words they're saying to each other.
So that brings us to part 3, privacy versus secrecy. We really need to understand the motives here.
Now that we've got a handle on the architecture, let's explore why people actually bother building and using these platforms. The distinction here is absolutely critical. Privacy is about protecting a legitimate confidentiality. Secrecy, on the other hand, is simply about making observation difficult. And here's the thing, the technology itself is completely neutral. Think of it like a curtain on a window. A curtain can provide perfectly legitimate privacy for a family just having dinner in their home, or it can be used to hide a terrible mess. The curtain doesn't decide, it just blocks the view. The same hiding properties that support vital privacy can also, unfortunately, support abuse.
Now, what's really interesting about this framework is how it lays out the totally unavoidable engineering trade-offs. You simply don't get these benefits for free. If you want more privacy, you inherently have to accept less convenience. Because the network is harder to map, it is fundamentally harder to trust. And while you definitely gain more potential for anonymity, you simultaneously create way more room for abuse. The whole system essentially trades openness for absolute control over exposure.
And because of these stark trade-offs, you see vastly different users operating on the exact same networks. On one hand, you've got journalists protecting vital sources, whistleblowers exposing corruption, and activists operating under heavy state surveillance. For them, this reduced visibility is literally a lifesaver. But on the exact same architecture, you're going to find marketplaces for illegal goods, stolen data trading, and extremist recruitment. It's a fascinating paradox. The precise drop in visibility that protects the vulnerable is the exact same drop in visibility that shields malicious actors.
Which leads us to our final section, Part 4, the danger of false confidence. This is where the real danger begins.
To understand the real-world risks, we have to shift our focus away from the network architecture for a minute and look at human psychology. The absolute biggest danger of the dark web isn't the network itself. It's false confidence. It's this dangerous assumption that just because you're on a hidden network, you're automatically safe. Remember our unmarked door analogy from earlier? Just because a room has a hidden entrance certainly doesn't guarantee the room itself is safe to hang out in. A hidden network dramatically reduces visibility at the technical level, but it absolutely does not protect you from phishing, scams, bad links, or frankly, your own simple mistakes.
Look at the massive gap between assumption and reality here. People naturally assume hidden means safe, and anonymous means trusted. But in reality, when a system is heavily designed to reduce visibility, it also strips away all the normal cues we use to judge trust. On the regular web, you've got recognizable domains, user reviews, browser warnings, and reputation systems. On hidden networks, those signals are almost completely missing, and that creates an incredibly fertile environment for scams. Hidden sites can easily be malicious, and anonymous actors can lie without any consequence, precisely because trust is so incredibly fragile in that space. So, the crucial point is this. Anonymity is never perfect. Never. Even with all this brilliant engineering, identity still leaks in the real world. It leaks through totally simple user mistakes, reused usernames, shipping information, device fingerprints, and payment trails. A hidden network makes tracing much harder, yes, for sure, but it does not make it impossible.
Which leaves us with this final powerful takeaway. The main danger begins when reduced visibility is mistaken for reduced risk. As we've seen, the dark web isn't some magical realm of crime. It's a heavily engineered system built on intentional friction and intense trade-offs. It protects and it conceals, relying entirely on the human behind the keyboard. So the very next time you hear a sensationalized headline about the dark web, just ask yourself, is the real story actually about the technology, or is it really about the age-old human flaws it's reflecting back at us?